Hey there, and welcome to my channel, The Paper Bag Investor. Today I want to talk about Tesla Battery Day, give my quick summary of it, and also I feel like there's a lot of misconceptions or misunderstandings out there about some of the key points about it. So I give sort of my take on why it's been so important and also why the stock has been dropping, or was dropping a few days after Battery Day. So let's get into it.
Goal number one is the terawatt-hour scale battery production.
So currently for electric vehicles, the world produces about 0.1 terawatt hours of battery capacity per year. And really to convert every vehicle that's produced every year and sold right now, you need somewhere in the order of 10 terawatt hours, which is 100 times what we currently produce the whole world. So it's a huge, insane problem. Really, they're just introducing the problem here.
Yeah, so it's a lot of batteries, basically.
And then on the grid side, we have a similar mountain to climb, 1,600 times growth from today's grid batteries.
And here they're really just introducing the problem is double-sided. We need about, as before they said, we need about 10 terawatt hours of energy battery capacity production for just to meet all global vehicle sales. But also on an energy storage side, we probably need a similar amount, about 10 terawatt hours, which are just insane amounts.
150 gigawatt hours per year is like what we probably expect to make out of there. But this is really pretty small in the grand scheme of things. That's only 0.15 terawatt hours. And it costs too much. So
we would need 135 fully built out Nevada gigafactories to achieve 20 terawatt hours a year.
And here again, they're just kind of explaining the magnitude of the problem. They could just take the current gigafactory in Nevada and build more of those factories. But even if that factory was fully functioning, which it currently isn't even, it would take 135 of those factories to produce 20 terawatt hours. So it's just an insane problem. And the need for innovation and rethinking the design of batteries and how they're manufactured from the ground up is so critical. So that's what they're going to explain to us.
So first, before we get too far into it, let's talk about what is in a battery cell. We've got the cap and the can, negative and positive terminals of the cell. When you open that cell, you've got a tab connected to those terminals, what we call the jelly roll, which is the wound electrodes on the inside. You can actually see what this looks like as you unwind it. This is over 1 meter long in a typical 2170 cell. So it's quite a long winding process. And you can see the tab still there. To explain what's actually going on here, we've identified we've got anode, cathode, separator, positive and negative terminal. Watch what happens as we discharge the cell. Got lithium moving from anode to cathode, and then the reverse. When we charge the cell, anode moving from lithium moving from cathode to anode across the separator. This is the basic of what makes all lithium-ion batteries.
This was just a great visual of how a lithium-ion battery works and is put together, and it's going to help us understand the rest of the presentation.
Yeah, and I want to stress, this is not just a concept or a rendering. We are starting to ramp up manufacturing of these cells at our pilot 10 gigawatt hour production facility just around the corner.
yeah.
So one of the first things Tesla unveiled was their 4680 battery cell, which is a larger cell with more volume, and the main advantage is that you can put more energy into the cell and it costs less to manufacture for that energy.
Yeah. It's a video of some of what's going on in the plant.
This is just some footage from their 10 gigawatt hour pilot plants, not 10 gigawatt hours yet, but they'll scale up to that. And really just for perspective, 10 gigawatt hours, say if you have making standard range Model 3s with 50 kilowatt hour batteries for 10 gigawatt hours, that's 200,000 vehicles worth of batteries a year that just that one pilot plant could produce. So even though this is just footage of a pilot plant, it still will be a big deal in the overall production. And just seeing these kind of clips and footage gets me excited for them trying to streamline the overall battery production.
You can see it here on a benchtop. Literally, powder into film. As simple as that.
I mean, it's hard, actually, just to be clear. Yeah.
What you saw before becomes this.
Yeah.
So you can see the motivation.
So basically what they're showing here in this clip is an idea of the dry system of applying the anode and cathode material to the separator. And currently that's always done with a wet slurry solution and then dried. But they're trying to find a way, which is why they acquired Maxwell Technologies, but they're trying to find a way to apply the anode and cathode to the separator directly from a powder form instantly on as a solid form. I think this was a little bit disappointing for some investors. It might be partly why the stock dipped in the few days afterwards, because they admitted this was really still at the pilot stage. So that may have disappointed Wall Street a little bit, but what does encourage me is that this is really, really difficult, but they are working on it. And I know that Tesla, in my mind, they're one of the most, if not the most innovative company in the world, aside from maybe SpaceX. And I know that if this is possible to do, they have the best chance of doing it and doing it in the shortest time. And if they are to achieve this, it would have a dramatic decrease in the capital cost to build a new factory and in the overall just production time and production cost per battery. So it's a really big deal, and it's something I know they're working on.
In the investment per kilowatt hour or gigawatt hour, it's just basically 4 times better than the current state of the art to the best of our knowledge.
In this clip, they're just explaining that if you put some of these technologies into practice, be it the Maxwell technology of applying the cathode and anode directly, but also the cell redesign when you're making larger cells, and overall rethinking how a battery factory works and the motion of all parts within it, then you can have a dramatic decrease in the amount of floor space for energy production required, which is really a big deal because these factories are absolutely enormous. And if you can reduce the footprint, it means you can put more energy output in the same footprint, which means you have a lot less capital expenditure for that energy output.
What we're proposing is a step change in capability and a step change in cost. And what that really is to just go to the raw metallurgical silicon itself. Don't engineer the base metal. Just start with that and design for it to expand in how you think of the particle in the electrode design and how you coat it. And how does it work? Start with raw metallurgical silicon, stabilize the surface with an elastic ion conducting polymer coating that is applied through a very scalable approach. No like chemical vapor deposition, no highly engineered high capex solutions, and then integrated into the electrode through a robust network formed out of a highly elastic binder. And in the end, by leveraging this silicon to its potential, we can increase the range of our vehicles by an additional 20%, just this improvement.
Yeah, it gets cheaper and longer range.
In this clip, they're explaining that rather than using these highly engineered and expensive lithium materials for the batteries, they're going to design the batteries to work with more lithium or direct from the mine. And I think it's very exciting what they're suggesting here, but and some of the chemistry is a little bit over my head, to be honest. And I wonder if Wall Street, the reason why Tesla dipped a few days right after Battery Day would be some of the comments like this. It seemed a little bit vague how this would actually be accomplished. But again, as a Tesla investor and a big believer in Tesla, I would want to give them a benefit of a doubt on some of these items. It's not like they just started working on their battery technology a few months ago. They've been doing it for years behind the scenes. And I would want to expect that they could possibly deliver on these sort of items.
So in order to scale, we really need to make sure that we're not constrained by total nickel availability. I actually spoke with the CEOs of the biggest mining companies in the world and said, please make more nickel. It's very important. And so I think they are going to make more nickel. But there's also, I think we need to have a kind of a 3-tiered approach to batteries. So starting with iron, that's kind of like a medium range, and then nickel manganese as sort of a medium plus, intermediate, and then a high nickel for long range applications like Cybertruck and the semi.
In this clip, they're just explaining that they're taking a diversified cathode approach, that really there's different cathode materials that will be used for different applications and for different markets around the world.
And these things just grew up as they're just kind of like legacy things that it's like how it was done before, and then they connected the dots, but really didn't think of the whole thing from like a first principle standpoint, saying how do we get from the nickel ore in the ground to the finished nickel product for a battery. And so we've looked at the entire value chain and said, how can we make this as simple as possible?
And that's what we're proposing here with our process. As you can see, a whole lot less is going on here. We get rid of the intermediate, metal, water, final product cathode, recirculate the water, no wastewater at all.
Here they're just explaining the cathode production and refinement process, and how traditionally there's legacy-wise how it's been done. It's quite complicated, and they have a number of ways that they've completely simplified that. I think this is another reason why some people might have been disappointed with battery day in general, because it seemed like a big bold claim without really clear explanation behind it of how they plan to do this. But again, I want to believe that Tesla again is in my mind the most innovative company in the world, and that they're I know in many industries there's the way things were done in a legacy way really doesn't make sense for today, and they're refining that and redoing that.
That then interfaces to what we call the structural battery, where the battery for the first time will have dual use. The battery will both have the use as an energy device and as structure. This is absolutely the way things are done. In the early days of aircraft, they would carry the fuel tanks as cargo. So the fuel tanks actually were quite difficult to carry. They were like basically worse than cargo. You had to kind of bolt them down. It was very difficult. And then somebody said, "Hey, what if we just make the wing tanks? What if we just make the fuel tank in wing shape?" So all modern airplanes, the fuel tank, your wing is just a fuel tank in wing shape. This is absolutely the way to do it. And then the fuel tank serves as dual structure, and it's no longer cargo. It's fundamental to the structure of the aircraft. This was a major breakthrough. We're doing the same for cars. So it improves the mass efficiency of the battery, and then those castings are also quite important because you want to transfer load into the structural battery pack in a very smooth, continuous way, so you don't put arbitrary point loads into the battery. So you kind of have to, you want to sort of feather the load out from the front and rear into the structural battery.
In this clip, Elon is explaining that with the redesign of their battery cells and ultimately battery packs, and with their single casting process that they started doing at Fremont, they're able to redesign and basically make the battery pack part of the structure of the vehicle and add stiffness and strength to that structure. This is a really important development and an interesting point. I think a lot of times when a legacy technology is developed for something else, it's really the ultimate design is thought of in the legacy way. So example, for battery cells, they probably hadn't been thought of to actually be designed in a way, the battery pack, that it could actually strengthen and add stiffness to the vehicle frame. One example I just thought of when I was making this, if you look at the very first vehicles, motorized vehicles that were created, were really actually just a horse carriage with a motor on it. And those are the first cars. It was a carriage with a motor on it. And someone didn't have, at that time, they were really just thinking about the old technology and implementing it with a new idea, rather than thinking about what's the best car we could make with a motor, with a gas motor at that time. And now in this sort of iteration, they're thinking, what's the best electric vehicle design we could ultimately make? Not just the best battery cell, but what's the best electric vehicle design we can make and implement?
Talking about cost or range, we've got to look at all the facets. So range increase, we're unlocking up to 54% increase in range for our vehicles and energy density for our energy products. 56% reduction in dollars per kilowatt hour at the battery pack level, and a 69% reduction in investment per gigawatt hour, which is the true enabler when we talk back about how do we achieve this scale problem here.
This is one of the most important slides and really the biggest takeaways from the whole presentation, that when you stack up all these different new innovations and technologies they've been discussing, they are suggesting if all those can ring true, you could have a range increase of 54%, and a dollars per kilowatt hour reduction in 56%, so more than half the current cost of the battery. And then the investment per gigawatt hour would also be a reduction in 69%, which just means your capital expenditure to build a new factory is greatly reduced. And these are absolutely insane numbers. As a long-term investor, I really like Battery Day. It gave me a lot of clarity and greater confidence in their long-term plan for the future. And I would think some people might not like a slide like this because there's a number of these technologies they've kind of said they're working on, but it's not absolutely clear if they're all going to come to full fruition. But even if they don't all come to full fruition, even if just a portion of them do, these are still going to be massive reductions and huge numbers in your range increase, in your overall cost at the battery pack level, that reduction, and in the cost to build new factories, that capital expenditure cost, which is really huge when you're trying to scale up these massive scales. So again, this is one of the biggest sort of takeaways as an investor, I would say, from Battery Day.
We're confident that long term we can design and manufacture a compelling $25,000 electric vehicle.
In this clip, they're unveiling that with all these cost reductions and efficiencies that they unveiled or they expect to achieve, that they think in the next few years they could have a $25,000 electric vehicle on the market. And again, I think some people may have been disappointed with Battery Day for some of these claims like this, where they're saying, okay, great, $25,000 vehicle, I'll be happy when I see it. And I think actually a few years ago, Elon already mentioned that they wanted to make a $25,000 vehicle in the future. So again, people are probably more wondering, okay, less telling us about it, more showing us. But that wasn't really realistic to expect that today at Battery Day. And what the kind of reductions they're talking about, I think a $25,000 vehicle, or even in that range, maybe it's $30,000 US, would be achievable. And the great thing, they also mentioned in the presentation, the great thing about electric vehicles is really the overall cost of ownership is quite a bit less. You can afford to pay more for the upfront for the vehicle and still have an overall lower cost of ownership than a gas vehicle, just because of all your savings in your maintenance and in your gas.
And we should probably talk about the Model S Plaid.
So something else they unveiled was that the Model S Plaid, if you don't know what that means, the Plaid is a reference to Spaceballs.
What the hell was that? Spaceball 1. They've gone to Plaid.
The specs on this kind of vehicle are actually just absolutely bonkers, less than 2 seconds, 0 to 60. And it's very, very exciting. I'm not a huge sort of performance car guy myself that gets really excited about that. But it is very exciting that they're able to make the world's highest performing vehicles, and at a very reasonable cost. $140,000 US is very expensive, but you compare this to the price of what other supercars would cost for this kind of performance, is just insane.
Yeah, so this is just for this is just talking about Tesla internal cell production. As I tweeted out earlier, we will continue to use our cell suppliers, Panasonic and LG and CATL.
Okay, this clip and this slide was actually done earlier in the presentation, but I wanted to leave it for last because I think it was one of the most important slides and bits in the whole presentation, other than maybe the slide where they showed the overall possible improvements in the battery range, cost per kilowatt hour, and capex cost. But this one is huge because they're saying that in-house production, they at Tesla, they expect to get to 100 gigawatt hours by 2022. And this is really in itself a bonkers number. Imagine if you had those 50 kilowatt hour Model 3s, a lower range kind of car, the smaller car. If you're talking 100 gigawatt hours, then at 50 kilowatt hours per car, that's 2 million vehicles could be produced for that amount, 2022. I mean, this year Tesla is expecting to sell or deliver about 500,000 vehicles, but in 2 years from now, maybe they could be delivering 2 million vehicles. Who knows? But then I'm really excited and happy to see that they have this really aggressive target of 3 terawatt hours of production, or 3,000 gigawatt hours of production, or which would translate to 60 million of those Model 3s in 2030. Now, they wouldn't be making all those sort of lower range models. Some of that energy would be going to energy storage, maybe even half of it, and a lot of those vehicles would be higher, larger batteries than just the smaller Model 3. You might have semis that have much larger batteries, and things like Cybertrucks that would also have want that longer range, longer batteries. But as a Tesla investor, this slide got me really excited. I did in my previous battery day video, before battery day, I was talking about how they might try and scale to 1 terawatt hour of capacity, say, in the next 10 years. But really, this is triple that, 3 terawatt hours, 3,000 gigawatt hours of capacity. And I'm very excited to see them aggressively pursue this goal. And I'm sure it wouldn't even stop there, because really what they said earlier on in the presentation is that they want really for the whole world 10 terawatt hours for the vehicle side and 10 terawatt hours for the energy storage side, so 20 terawatt hours total. So I'm sure 3 is really just the beginning, but it is a huge goal in itself, and they're aiming for that for 2030 is very exciting for me as a Tesla long-term investor. Anyways, that about wraps up my video. There's other details in there. I couldn't put it all in one video. They talked about recycling as well, which is very exciting. But yeah, that gives you some summary, and I hope clarifies some of the misconceptions and gives you some idea, I think, why Wall Street reacted negatively, because some of the claims were kind of big grand claims, and was not totally sure if they're going to execute on that. But I really think Tesla will. Some of their timelines could even potentially be sandbagged. What do you call sandbagged timelines? Because they want to basically push, say, the timelines out in the future further than it really is, so that people don't stop buying the current vehicles that are made right now. And that could very well be partly the case as well. But if you enjoy this video, I really encourage you, hit that subscribe button down below if you got value out of this video. This channel, I'm really trying to look at investing from a long-term growth perspective and look for high return companies. And if that's something that really resonates with you, I encourage you, hit that subscribe button down below. And yeah, this is the Paper Bag Investor signing off. Thank you so much for watching. Bye.